Hello everyone, and welcome back to this rather short video in which we are going to implement the linear load distributed in the controller. It's going to be shorter because I realized by mistake that I only need to implement the generation of the load because the application and deletion has been polymorphized. Now this is not really polymorphism because polymorphism is something advanced in programming, especially with inheritance, but it works just fine. Now, of course, if you are new to this video series, please notice that this is part of the Finite Element Method video series linked on the top right. And if you stumbled upon this video by chance and you're wondering how did you even get here, then you can double check the video series about the programming, which is also linked on the top right. Now, as per usual, I want to remind that the entire source code is available to my dear channel members. And if you are not a channel member, then don't worry, because I'm not hiding any code from you, but you have to write along with me. So with that being said, we're gonna dive into the controller, so sit back, relax, and enjoy the show. Alright, this is gonna be rather a shorter video, so let's get to do this and maybe try to keep it under 4 minutes or something. So here I'm gonna say line load distributed region, and here I'm gonna basically give a function that adds an str line load distributed. Now here I need to give a ton of stuff. So what I will be doing is I will be copying this entire stuff. I should have copied it in the beginning. And yeah, I'm just going to replace it here and see what I can change. Now, first of all, this becomes fx start, fy start, fz start, mx, my, mz, and relative location at the start. And then I'm going to do the same thing for the end because I need to provide the starting values and the ending values. So those are going to be the ending values. So I'm going to replace the s with an e. Now here, it wants to get a new ID and it wants to save stuff. However, this doesn't work because I don't have an ID system and a saving system for that. So str line load distributed equals ID equals 0, and I need the storage system for this. So I'm going to call this str line load distributed s distributed. I know the correct way of English speaking is str line loads distributed, but I'm going to put the s here for funsies. All right, now let's change whatever we need to change here. So here it tries to increment the concentrated ID. That's not the case, because we want to talk about the distributed ID. So that's the one that gets incremented. Here, the same thing, I get the distributed ID. And here I want to declare a distributed str line load. Now here, this needs a ton of inputs. That's not enough, so I need to give the starting value. And I think I can just copy this because I want to speed up my production. So enter, paste. And now let's append s's and e's. So s for each one of those, the starting values, and e for the ending values. So those are the s's, and those are the e's. Fantastic. So this is the constructor of the thing. I think that's it, right? No, the storage has not been done correctly. I need to store it in the distributed thing. Can I multi-storage? I think I can multi-storage in MATLAB, but I don't want to run an is check statement, so I just keep it simple like that. And I think we're done. Now it's time to try. So to try, I'm going to go to the main, and I'm going to replace this. Where is it? I'm going to replace the load distributed declaration, which I do by hand. I'm going to ask the controller to do it for me without giving the ID. So controller, in small letters, dot add str line load distributed, and this time I don't need to pass in the ID, and I don't need to ask it to do to string because the reporting system in the controller is going to take care of it. Speaking of which, I haven't done that, so I need to copy this stuff and paste it and let the reporting system handle it. So this is linear loads distributed, which means I'm going to check out the str line load distributeds. I'm going to pick out one of them. This is a target line load distributed. Of course, I'm going to ask it to report itself. And I think that's it. Let's put it to the test. So let's run that thing and see what happens. So okay, the run has been completed. We have the model and we have this stuff. So line load distributed at 0.4, 0.6. Yeah, everything seems to be fine. Apply to is empty. Why? Oh, I forgot to apply something. So you just copy this, and paste it here, and put it to the test again. See if you get 1, 2, 3, 4, 5. And we don't get it. Ah, that's a bummer. That is no, not a bummer. I need to, mistake. I need to pass it for the distributed load. Let's try again. And there we go. It works perfectly. So yeah, I think we have once again achieved another milestone in this programming. And I think I will stop it here. So with that being said, that's everything I wanted to talk about today. I hope you enjoyed. And in the end, I want to give a improved distributed sized shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support of the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on, especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.